Welcome to the module on thinking about data. In this module, we will learn a lot about different types of data, and particularly we will talk and learn about the kinds of data that you hear about in the news, such as big data. We will talk a little bit about data mining, although that is outside the scope of this course. So in order to learn about data, let's talk about what data really is, what big data is, why data is important, and why in the world we're learning all of these things. Let's start by talking about what really constitutes data and what types of data we are interested in looking at. What really is data? Data is anything that is recorded or collected and presumably can be used in some way. Now, often data is collected in a hidden way. We talked a lot in the privacy chapter about digital fingerprints, and that's one way of collecting data that is hidden. There could also be surveillance cameras that could be collecting data about where you are at any given time. Data can also be collected in plain view or something you gave permission for. For example, when you get a credit card, every single transaction you make on your credit card is recorded, and they store that history for as long as you may have that credit card, and they can use it to figure out what types of things you like to buy. In a related example, all monetary transactions are recorded through your bank, so everything that you deposit and everything you write out through a check is recorded. And if you deposit too much money or send too much money out, it's actually reported to the government. Cars and airplanes have black boxes in them that record data about how fast you're going and everything that you are doing, where your seatbelt's plugged in, etc. And if you get in an accident, the insurance company can pull that information from your black box. A lot of people don't know that, but it's there. Another example of data in a completely different venue, there are sports statistics on every player in every single sports venue out there. And you could use those statistics presumably to do better betting or just learn more about your player and learn more about the game. As a final example, everything that is sold on Amazon is recorded, and that's how they're able to do things like other people who bought this book also bought this and sell you more books. The data that you will use in your lab in this section will be on temperature readings and other weather readings outside in Oklahoma. You can imagine medical data such as heart monitor readings or pandemic detection. That is, you're trying to see who's buying cough syrup, where it's being sold, how much, and is there a trend. Another neat example of medical data is the firing of your neurons, and people use this data to do something like prosthetic limbs. So if you can have an intelligent prosthetic limb where you can figure out what neurons are firing that would have controlled the limb that is now prosthetic, then you can actually have a prosthetic limb that is correctly controlled. Now, all those medical examples have convinced you that medical data is very diverse, but how about in addition to the data that they collect at Amazon, every store, everywhere you shop, actually collects data. So Walmart or Homeland or any other grocery store out there, they collect everything you buy in every single basket. And that's how they give you the coupons to try to bring you back next time. So let's talk about what big data really is. That's a buzzword that you hear thrown around. You'll see it in the news, but nobody's actually really defined it. What is big data and why is it interesting? Well, let's start with the definition. There really isn't a formal definition of what big data is. Big data is just a very large data set that can be collected these days that couldn't be collected before. So disks are getting larger and cheaper, and data is getting much more available. And at this point, the definition I'll give you for big data is data that is so large that traditional hand analysis techniques will not work. Big data exists in almost every field that there is. Let's have an example. One example, we talked a lot about medical data sets. So look at large medical data sets. There exist databases of heart patients, for example, that have 25 or 30,000 patients in it, or cancer data sets that look at all of the cancer cases in one area of the country, and you can imagine that that could be a large data set. Another data set that's pretty interesting, health insurance companies will collect data on every single patient that they have, and if you look at large companies, that can be a lot of data. So another example of a large data set is that of weather prediction. Weather simulations can be run in a number of different resolutions, but at the highest resolutions where they're trying to simulate the atmosphere in as much detail as possible, they can generate terabytes or petabytes of data. So for example, one of the things that I work on in my research is trying to predict tornadoes and looking at hail, and we have simulations that generate these large quantities of data, and we need to be able to analyze them. Related to the weather prediction, another data set that I work on that counts as large data is that of airline turbulence prediction. So for this data, we collect commercial airline data every 5 minutes. We're collecting whether or not it's turbulent and the actual measure of their turbulence every 5 minutes for every single airline that's out there. That's a very large data set. Go back to your example of the purchases from Walmart too. If you imagine every purchase from every cart, from every person in every single Walmart all around the world, and you collect that every day of the year for years and years, that's a very large data set. Definitely not something that you can analyze by hand. Another example of big data is that of genetics. So your genetic information is a very large data set, and trying to figure out what causes more than simple things, like they know what causes a blue eye versus a brown eye, but something like diseases is a very tricky thing to do. As a final example of a fun big data set, imagine collecting the information on every call and every text that you've ever made, and then collect that data for every single person in, say, one country like the United States. You can imagine that could be a very large data set. What do you do with it, and how do you mine it for interesting patterns? Why is big data important? I've convinced you that there's a lot of interesting big data sets out there, but let's talk about why it's important. Well, for one thing, in science and engineering, big data can be used to make a lot of fundamental transformations in our understanding in the world. So I'm going to use the example of the data that I work on. With the severe weather data, we are trying to be able to fundamentally transform our understanding of how severe weather forms so that we can improve the prediction of severe weather, such as tornadoes and hail. Big data has existed as a concept for a while. That is, we've been able to collect some of this data, although we weren't always able to store it. But why is big data a buzzword right now? Well, the reason that it's considered new and a buzzword is that we are able to actually not just store the data, but actually process it. And by we, I don't mean just educational institutions or places that have supercomputers, but there's commercial access at this point to the power and the data necessary to do this mining. So for example, in the last election, there was a considerable amount of data mining trying to target the swing voters and figure out which way they would vote and figure out which ones needed more attention. And another example, supermarkets. They use this data that they're collecting on everything that you buy in order to be able to smartly stock their shelves so that things don't go bad and they don't have to throw them out. So I've convinced you that there's really interesting big data sets and that we can use them to fundamentally transform our understanding of interesting data. But let's talk about what does that mean? How do we do that? Well, the way we do that is another set of buzzwords that you've probably heard about or read about called data mining. And generally, the methods for data mining are beyond the scope of this course. There will be a little bit about it in the videos that I'm going to have you watch. But let's just briefly give a definition of data mining. The idea behind data mining is to find patterns in very large data sets. And particularly, we want to find interesting patterns, patterns that are useful to the person who's seeking these patterns. You don't just want random patterns, because those do exist in any large data set. But we want patterns that can be used for something. So as an example of patterns that can be useful, let's talk about patterns that can be commercially useful first. So for example, can you predict what product will be hot for the holidays? You want to have a lot of that product in store, and you want to be able to make it in time to have it ready for the holidays. Or how about, just aside from the holidays, how can you place items on a shelf so that you sell more? Is there something that you can put next to each other? So two items like peanut butter and jelly, for example, that go well together that you put next to each other so you sell more of them? So aside from patterns for commercial usefulness, how about patterns to save lives? Can you figure out what combinations of genes make a person immune to a particular disease? Or can you figure out how to fix an error in the genetic code? Well, first you have to be able to find what the genetic code for that disease is that's triggering it. Or how about what drug combination will cure a particular disease? Another example that a lot of data mining research focuses on is trying to predict the stock market. Will it go up today? Will it go down today? Which stock will go up? Which stock will go down? There are a lot of data miners in the stock market all trying to figure out how to make money. If it was easy, well, we'd all have a job there. But it can be fun, and it's an interesting, very large data set. So what are you going to learn about in this module? This has been a good introduction to data. I have a bunch of videos about data that I want you to look at that will show you a lot of different examples and applications of using data in different ways. The learning objectives for this module are to use computers to process information to gain insight and knowledge. And the way that you are going to do that is you're going to use the computer to improve your understanding of Oklahoma weather. You will also be practicing your more complicated logical thinking by making more complicated programs. This will be a more complicated program than any of the ones that you've done before. And you're going to use this Oklahoma weather data to understand how the weather changes here. You're going to learn a lot about data in this lab, both from the outside videos, which will show you a lot of different applications, and from your work on the Oklahoma weather data. So let's go have fun learning about data.